Okay, good morning. Welcome to
FamilyMath320a.
320a, sums of divisors. So this wraps up our week talking about divisors. We started by talking about the product of divisors.
Yep.
And how do you find the product of divisors? What do you do?
So you factor it into primes.
Okay, so let's say take the number 20. What is that when you factor it into primes? Can you tell me?
It's 2, I think it's 4 times, 2 squared times 5.
2 squared times 5. Okay. And what do we do?
Well, then we say we have 3 choices for the amount of 2's we can use.
Okay, so if we're going to look at a random divisor, we can pick how many 2's?
We can pick 0 2's,
1,
1
2,
2, or
and
2
2
2's.
2's.
Okay, so we have 3 choices for the 2's. And how many choices do we have for the 5's?
And just 2 because it's only 0 or 1 5.
So the 5's we have 2 choices. So how many
There's
divisors are there?
6 divisors.
6 divisors. Okay. So today we're going to learn a way to find out what the sum of those divisors is. And maybe just for fun we should look and see what they are. What are the divisors of 20? There's 6 of them.
1 and 20,
1 and 20.
2 and 10, and 4 and 5.
Oops. Can you make sure that I'm on screen here? 4 when I'm ready. Is that 5 on screen?
Yeah.
Okay. So what does this sum up to?
Well, you have 7 plus 35, and that's 42.
Okay, so the sum is 42. Okay. So we're going to find out a way to see reasonably quickly that the sum is 42. Just like we could see that the number was 6 without writing down what they were. So today we're going to learn about how to find that the sum is 42 without writing down what the divisors are. So it's kind of cool. It's kind of cool. But I also want to say that this is an interesting math problem all by itself. So how would you suggest we begin to try to understand this problem?
Well, we could maybe try like a simple example, like maybe 2.
Okay.
We could see how 2 has the sum of its divisors equal to 3.
Okay. That's a good idea. We could start with 2. What are some other simple cases?
Well, the prime numbers are simple cases.
Because they only have 1 in itself.
Very good. So the prime numbers are simple cases. Sum. If we have a prime number p, the sum of divisors
It's p plus 1.
is p plus 1. Okay. So that's not too hard to understand. And why is that true, by the way?
Well, because you only have the prime itself and 1, and there are only 2 divisors.
Okay. And prime itself in 1. Okay. Now, here's really the most difficult challenge in this problem of finding out a formula for the sum of the divisors. What's the next simplest case, do you think?
Well, the numbers that have 3
Well, maybe the squares of primes.
squares of primes.
Oh, interesting. Why would that be a simple case?
Well, you have the prime squared in 1, and then the prime, and then just the prime.
Okay, so what's an example of a prime squared?
So 4 is 2 squared.
Okay. So if we have a prime squared like 4, what's the sum of the divisors?
Well,
We have 4 and 1 and 2. So it's 7.
The sum is 7. Okay. How about another prime squared?
Well, 3. Well, we have 9 squared. No, not. We just have 9.
Okay.
So that means we would
9
have,
and 1.
yep, and then
3.
3, so 13.
And I'll continue my chart over here. P squared and sum. Okay, what's the next prime squared?
Well, you'd have 16. Or, no, that's not a prime, so it'd be 25.
25. Okay. What's the sum?
125 and 5.
which is 31.
31?
So how would you get from this number to this number?
Yeah. Well, if we did it in general for a prime squared, what is the sum of divisors? If I have a general prime, p squared, what's the sum of the divisors?
Well, it would be p squared plus p plus 1.
Is this on camera? It's my plus one on camera. By the way, how much time have we gone here? 5 minutes?
Looks like it's on camera. Wait.
We gone
Yeah.
5 minutes?
Yeah.
Okay, let's move on to the next one. So we got a formula for prime squared sum, p squared plus p plus 1.
Okay.